Wow, wow, wow. Dude. Hello. Yeah, this is what we're going to be doing. I said stroke. That was weird. Wow, wow, wow. Wow, wow, wow. I made all of this, and I'm so proud of it. I hate programming in C so much, though. It's the closest thing we're going to get to, like, rock music right now. It's Noida soundtrack. I'm just making utility stuff. I have a stride array. Basically what this is, it's just an array. It's like an OpenGL. You could set a in OpenGL, you have like a pointer attribute where you could set the stride, which is like how many bytes are in each like section. So you could do that. You could set the stride array of integer, and you could push stuff. Someone's going to complain about this though. I don't care. Someone's going to say, "Oh, this is disgusting. Look at this. Look at that. You could use some like weird like bit shifting." I don't care. Wait, I literally can use bit shifting though. I could just resize it, move it around. Whatever, this works. What I was thinking with the bit shifting, if we have like a thing of 1, let's say we want to insert something right here. We can get these pointers, allocate. Wait, I literally could just do that. I could just reallocate it. I could just do this. Reallocate. This is a different thing. Then we shift it over. And then there we go. Oh, it doesn't work. Oh, cool, it crashed. Oh, there we go. It's fine. And then we could just insert it, but I don't care. Look at the speed of it. It's not. Look how epic. Yeah, look at the speed of it. Puts like the most basic amount of instructions ever. Just mem copy and then mem set. Yeah, of course it's going to run at like 1,000,000 frames a second. Nothing's being compared. Well, mem copy probably has some weird stuff going on. Same with memory allocate. Okay. I got a mono microphone. Oh yeah. There doesn't seem to be a memory leak. If I delete it, this is fine. This is fine. This is fine. Okay. I think yeah, I think pop-at uses 3 arrays. This could definitely be improved. Like literally all I could do. No, am I doing what I think I'm doing? Yeah, I'm copying it to an auxiliary data array. Reducing the size, fall off size, which is like the right side. It's like how many bytes are how much information is after the split. So we could shift it over. So this works. I am so happy that this works. So this took me like a day or a couple hours. It took me all yesterday. Not all of. When I got home from school. Oh fuck, tomorrow's gonna be a 1-8 day. Oh. What is it? Is this that song? Kurva. No, it's not. Look at this. Open, make a breakpoint at destroy. This is going to say ace. Location. It's awesome. It's epic. There's some weirdness, like resize. Resize is the most laziest thing ever. It just memory allocates it. Clear, freeze it. And I think shallow duplicate works. It worked. The way I did it before is just duplicate the entire thing. But the location variable, which is the first byte, or the pointer for the first byte of where the data lies, and I was duplicating the pointer, not the actual data, so that I had to do some stuff right here that actually copies the data. What did I do here? Copy location. Oh, yeah, copy. Make a new thing. Then I just copy the data. Wait, is this redundant? Wait, I don't need this. Why did I put in for loop? Oh, so I could dereference it. I think. Wait, no, memcopy already just. Right? Can I just? Because memcopy copies data from a pointer to another pointer. So if we do memcopy, copy location destination, then I do array location copy byte size, then this should work, right? Unavailable debuggy. Alright, now let's duplicate it. Copy. Now stride array copy. Copy equals stride array shallow duplicate. Alright, let's look. Alright, it should say ace backwards, and this should also say ace backwards. Yeah! And then if we do array. Okay, then I do array, no, stride array set index array data f index 0. Say yep, and this should still say ace. That's awesome. That's great. Okay. That's gonna help a ton when I try and make a scripting language. I did just say that. You heard me correct. I am going to attempt to do that. I have ideas on how, because at the end of the day, it's just a list of instructions. Now, I know there's a lot more stuff that I don't know that's going under the hood. That's like to make sure stuff works. Maybe like having just an array of instructions is probably a bit naive. Like, what if you want to add like multi-threading and whatnot? What if you want to add something in the middle to maybe like have debugging? Then you're going to have to rewrite it. And matter of fact, when I say rewrite, I mean, or I meant to say, you might have to refactor it first. But then sometimes you might actually have to rewrite it. It was a gaff. I learned that from my English teacher. It's crazy. Alright. Oh, print F. Full F. For volatile int 0, x is less than. I learned this little thing yesterday. This is going to take it's a what was that? That was weird. What was that? But what? Hell. Let's try a million instructions or a million things. Oh. Snap. Next. No. Oh, this is good music. Oh, it's in the left ear, and I have my headphones slightly off, so I can hear myself. Because, like, if I have my headphones on, I can't hear myself at all. God, do I want to listen to this right now? I want to listen to this. I don't know what that is. 51 views, that's great.
Black hole sun. Fuck. Oh.
I don't know if this is the thing. I don't know if this stuff is naive or not. That's the thing about programming. It's like, oh, let's implement a system to like track how long it takes to execute something. Completely wrong. It's completely wrong. You need to be doing this weird thing. It's like, I don't know. Just. I'm just yapping at this point. Okay. Yeah, I think that was actually just what you'd call a straw man argument. Like, I literally just made up something. I don't think anyone has ever said that. I think my headphones are on backwards. Whatever, we're past that. This is the thing about these, you have to make them so freaking efficient. Seriously, I don't know if this is laggy or not. Or it's not, I mean, but like, no, it's C. Jesus. It's like, this is one call. I mean, there's probably a whole bunch of weird stuff going on under here. This is a header file, so I don't know what's actually happening. I don't even know if you can even access the source code. General dependencies. Source annotate. Oh, I thought it was animations. Animation. Excuse me. Wait, I need to see something real quick. Why is Power World so popular? I don't get it. Maybe I'm missing the point. Maybe I'm just being sour, but like, I just don't know. It looks like an Android game. It looks like a... Oh my god, I'm getting off of Twitch. Oh, I got comments on my video. It's the 24th. You can tow off their ships in the ATV. Voice of the Void documented part 2. You can tow off their ships with the ATV and hooks. Also, you can hit the lantern by holding it and pressing on your What? Wait, what? You can tow off their ships with the ATV and hooks. What are you talking about? I guess he's talking about the drones. I don't know. Because you can hook onto the drone and just like fly out. But like if you go far enough, you're gonna clip into a wall. And you're gonna break. You're gonna soft lock the game. You can take the lantern by holding it and pressing dot on your numpad keys. Doing so will teleport you back to the base where you can stash it in the basement or something while they get or slap. Oh, he's talking about. I thought he was talking about the regular lantern. No, he's talking about the arrival lantern that you find at the treehouse. Cool. I'll try that. Matter of fact, give it a like. I realized today is the 24th, though I already did the Bad Sun event. That's cool. Good for you. Cool, alright. That was loud. What if I delete all this? What would happen? Would it break anything? No, I'd probably just... It's either all of this is like linked, or it's like, I guess, local, like it's copied. So either if I delete this, if I delete everything and save, I will either have to reinstall, or just like, I don't know, like I guess there's like a validation thing that you could probably do. Reinstall like all the stuff. Okay, when making a scripting language, there's like an intermediate thing. Not intermediate, there's like a... Well, I mean, yeah, there is. But not what I was thinking of. That would be like the compiler. That'd be like the parser, which parses into, Okay, this is how I think a scripting language would work. Is okay, you have a script, and you have a parser. The parser reads the script and tries to, like, convert it into, like, I guess bytecode. Is what you'd call it, something. Well, bytecode is like, I think, like how C it compiles into assembly, I think. I don't know. But it, like, compiles into something that is, like, not human readable. Or not easy. Okay, you have the script. It's converted into bytecode. You do this probably to optimize. So, because trying to parse something in real time with, like, text, it's going to take a lot longer than just simply saying, do this next, and do this next. And so you do that. Okay, you have the bytecode. You have the compiled. Well, it's not compiled probably. It's like whatever, interpreted. I don't know the terms. And then you would have, yeah, an interpreter to run it. This is how I want to have the scripts, though. Like, I want the scripts to pretty much not be like... Okay, my idea of the scripts was to be like a hook. Just to, like, simplify a bunch of stuff. Like, you can hook C functions or, like, C variables into some, like, wrapper thing. Like, okay, I want to send this information into a script. This is how you read this information. And then run the script. And then you get an output. That's pretty much how I want to do the scripting. It's like a black box. Well, it's not, you know what's going on. You send information, it does some fancy stuff, then it makes an output. Wait, isn't that like how GLSL works? Technically? I mean, it's not... Like, you have inputs and then you have outputs. Like, in... Like, this is how I was thinking of it. Like, this syntax. Like... This is how I tried to implement it before. So, like, you do, like, script... Create... Script... Then, like, you'd bind a bunch of variables to it. Bind... No, you'd have, var equals... script var create, and then like script var set type, blah 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 blah, and then you set the data, var set data, which would be a pointer, so it just copies it. What's this like caveman music I'm listening to? Then I could do like script execute, which it would run like a main function, like a main scope. Because the script would act as one big scope. It's so tricky because when I'm trying to implement it, I'm trying to think of like a really simple way of implementing it. Like, I had ideas. One idea I eventually thought of was, again, everything's basically inside a script, or a scope. So the entire script is a scope you could just run. And it executes. And then it's like scope inside scopes and stuff. And the way I was thinking of handling scopes is, this is what it does. Okay, you have a scope, but then it like, it puts it into its own thing. Each scope is its own little special thing, and then you can invoke a scope. Oh wait, what if I have like a scope list, or it's like a stack? Like, I have a scope, and then if this scope invokes, okay, you have instruction inst A, B, C. Now, instruction C says, I want this scope, I want to run this scope. And so it does that, and then it... Then it just copies these and puts it right here. Could that work? Then again, you don't really even have to do this, because you could just do it in runtime. Like an inline thing. Or not runtime, in compile. Like, instead of going, oh, let's copy it right now, we could just say, oh, let's read it, and this is going to call this scope Instead of doing it while it's running, let's just copy the instructions right now. That probably made no sense. It's going to make sense. I was thinking like how inline works. I think it's how it works. It just like copies it. Or, whatever. Alright, what should I make next? I'm just trying to like just make stuff. Just see what I can make. I feel like this was a great practice practice. This was great practice trying to understand how like memory and like pointers work. Like, oh my god, this helped out so much. Cause I don't know if I already said this. Oh wait, no, I didn't. Like yesterday, I wasn't live yesterday. But like how I thought like pointers worked was, okay, you have a pointer, and this points to a group of memory. Like, let's just say like this. No, a pointer points to one byte of memory. So what I was thinking Malik. What I thought Malik was doing was, okay, return a single pointer that points to 10 bytes. No, what it's doing is finding a place in memory that has 10 consecutive pointers, or 10 unallocated pointers. And then what it does is returns the first pointer in that contiguous mass of pointers. Which I don't know why that took me so long to figure that out. I figured that out on accident, I think. Well, I mean, yeah, most of the stuff. It's me just doing random stuff. Yeah, I was using... Maybe. No, yeah, I was trying to figure out how to, Because I was still... Okay. Yesterday, when I was implementing this, I still had the idea that it was pointing... Like, a pointer was pointing to an array of bytes. So I was like, how do I access memory? Or how do I access a byte inside of this array of bytes? Probably didn't. No. Yeah, I was still thinking that it was doing this. This points to a group. But then I realized, oh, what if I add 1? Next thing I know... No. I don't know how I figured it out. I forget. It was something like that. Now it's time to make a renderer. That's great. No, what should I make? I was thinking like a PEMDAS thing. Maybe I can make a something that is like a calculator, like an equation calculator. Boy. Excuse me, I keep burping. Equation calculator. I'm just gonna say stride array works. It should. I mean, I don't know how it wouldn't. Off. Alright. Equation calculator. And if, alright. Type def struct. People are probably gonna yell at me for doing this. Doing this type of syntax. I used to do it like this. Type def struct. No, I used to do, what'd I do? And then I'll do type def. I'll do struct. I used to do that. Now I just do this because it just seems like nicer. I mean, like, oh yeah, this does work. Some people are probably going to complain, oh, it's not right next to struct, so you can't figure it out in like 0.2 seconds. I don't care. Yeah, if it works for me, it works for me. Equation calculator. So let's think about this. So, okay, let's document it. A calculate. Oh, this is that song. The song I was thinking of earlier. A calculator that computes calculations. A character. A string. That's an equation. So let's try and follow PEMDAS. PEMDAS. So this is something I didn't figure out, or I didn't know about until just recently, how PEMDAS actually works. So let's say you have this. 5 divided by 4 times 4, 32. I think... So what I used to think was, oh, we multiply this, we get 4 times 30, no, let's do something simpler. We would do, okay, no wait, plus 2. Minus 2 plus 1. I used to do this like this, okay? Oh, parentheses, okay? There's nothing here. We just multiply. Because this is first, right here. No. What it actually means is these are the same. Okay, let's get all the division and multiplication and find the leftmost one. We do this one first, apparently. I used to do it by do all multiplication, do all the division, do all the addition and subtraction. Apparently it's not like that. It's again, I'm trying to explain it better this time. It's you find all of the multiplication division things and you kind of like group, or you do this in your head, not literally, but like, okay, you find all the multiplication division, you find the first multiplication or thingy. The first one is division. This is what you're supposed to do. All right, let's just. I used to do it like this. 4. So this has become 8. Then we divide. 4 divided by 8. I think that's 0.5. Because if it was 8 divided by 4, it'd be 2. Because we cut 8 into 4 separate things. 2 times, yeah. But it'd be 0.5 minus 2 plus 1. Then I used to do plus. This would be 3.5. Wait, let's see. Let's see if my math is even right at all. But apparently this is what you're supposed to do. 4 divided by 4. 2 minus 2 plus 1. Unless people are facepalming right now, the 0 people watching. This is what you're supposed to do. Let's make 0. This is 2. We still have 0. Minus 1. 1. Let's be negative 1. Watch me be completely wrong. This, I swear to God. It's 1. Huh? This would become, no, yeah. This becomes 0. Oh, wait, I am such an idiot. 4 divided by x equals 1. Holy. Oh. God. I forgot how to math there for a second. Alright, this is 1 times 2, which is 2. So it'd be 1, yeah. Okay. Oh. But no, it's weird. Find all. Let's just like. Okay. Sort. From deepest to highest. Meaning. If we do something like this, x, y, z becomes z, y, x. Because, okay, yeah, how I want this equation calculator to work is it doesn't really... Okay, it reads through it, but then instead of following PEMDAS itself, it just, if you have something like 4 minus 2 times 3, it doesn't do 2 times 3, 6, 2. It literally just does 4 minus 2. It's 2, 6. It goes 1 by 1 instead of following PEMDAS. Also, it truncates, it just omits that and converts it into that. Exponents. Okay, I have an idea. First, instead of doing parentheses... No, never mind. Okay, what if we want to do 40 plus 10 to the power of 3? So we'd want to do parentheses. No, yeah. Okay, what we could do is we calculate all... Okay, I have an idea. We have like a simple like straight equation calculator straight, which is it's just straight line. It just calculates. It doesn't follow any rules. It just says, okay, first we add, then we subtract, then we might divide. There's no exponents, stuff like, oh wait, no, exponents. It's just forward. It's just brute force. Okay. So I probably don't even need this. I mean, I could use this for like maybe like debug stuff. Like equation calculator might hold data. Oh, I mean, yeah. But I mean, it could hold stuff. Oh, I have my thing on. There we go. Maybe how long it takes to do the equation? Or just like extra stuff. Maybe how many parentheses it had to compute, whatever. Like a log, I guess, of an equation. We could do that, and we could name it log or something. Actually, let's just get rid of it. Okay. Short parentheses. No. Compute all per... Put sort parentheses equations. Oh wait, no. Okay, I don't know if this would work because what if we want to do this? 4 times 4. What if we want to get 16 like that instead of 4 times 4? Okay, let's have an equation and just like figure out. Okay. Power of 3. Okay, let's just try and figure this out like a human. Alright. 2. So we find the deepest one, and then we calculate it. We put it into a straight calculator. Then we get 6. Put into a straight calculator, which returns 6. And then add calculate exponent. No. Okay, what if a parentheses has attributes? Like a parentheses could be, it could be a function actually. Oh yeah, what if we do that? A parentheses could act like a square root equation, but instead of computing square root, it just computes a straight calculator. But if you put square root before it, or like squirt, what? SQRT, then it says this is a square root parentheses, not just a straight like a straight equation. Oh wait, no, we can't put it through a straight calculator because this is... Calculator base. Oh wait, no, this is a header file, we can't do that. Calculates a simple equation. Oh, I'm gonna have to... Oh. You got expressions. I think I forget the difference between an expression and an equation. One of them is just straight up just like, okay, 4 times 2. The other one is like 4 times 2 equals x. Where x you're gonna have to like oh god. Now I'm gonna have to implement a system for that. This just got 10 times more difficult. Great. And then if you want to do calculus, good luck. I'm no. Well, I mean, that's not too hard. It's just instructions. Yeah, it's just a list of instructions. Oh my god. No, I'm not going to add that. I'm not going to add like an expression thing. Equation. I was actually about to just write it as equation. So base, yeah, it just takes in just a simple. It can't understand what this is. It can only understand things like 4 times 2 plus 1. It can't do parentheses. Okay. Now let's try and think of this a different way. Okay, we have a variable var equal output equals 0. Okay. Plus 2, 4 divided by 9, power of 3. Okay. Sort parent from five times 5 plus 9. All right. Remember its tag. All right, so we have do this. It'd be 5 plus 9. No. Oh god. Okay. What if we put each parentheses into its own like special intermediate thing? So we have like a struct equation parentheses holds because what I was thinking of, okay. No, you can make this simple. Come on, simpler. Come on. Oh, there's another outtake there. Because, okay, you calculate this, but it doesn't know. Because I want the system of just lining expressions. No, I just want the thing. I want to be able to just line arithmetic up. I can take an equation and I can convert it into just a line of instructions. But then exponents wouldn't work right, because if I was to do this and convert this to like a list of instructions, it would exponent everything instead of just this stuff. Unless it's... No. Because it would also exponent this. Hold up. Let's see. If I was to turn this into a list of instructions, I would do 3 plus 2 to the... And then this would power these. This wouldn't be 3... This wouldn't be 2 to the power of 3. This is this, compute this, which would become 5. And then become 25. Oh no, then what would this...
Oh, God.
This is tough. This is real tough trying to make something that doesn't like break. I've been doing this. I haven't written an actual line of code for an hour. I need to take a step back from this. I know I just started an hour ago, but I need to take just a step back. And just like I don't want to just go straight to programming, okay? I kind of want to just chill out. I'll probably come back later. Okay, or I'll just do this offline. I don't know.